afternoon, good evening to all. Sorry to keep you waiting. Is my voice audible to all? Okay. Okay, right. So let's go on with the today's class. Our today's class is on IT networking. Most of you people are hearing terms such as LAN, MAN, WAN. You are hearing these type of terms in IT networking. Then you are hearing the terms like topology. Then you are hearing terms like routers, switches, network cables, etc. So these are all the terms related to IT networking. On the IT networking is a term associated with IT infrastructure. So we can say that IT networking is a part of IT infrastructure. The window seems to be okay. Renzi, the window is okay. I mean, I have maximized it. So from my side, it's okay. You check the settings at your end. Just log out and log in once again. I think that will solve your problem. So whenever you are connecting two systems, yes, or suppose you have an office which is having 500 people at one place and say 500 people at any other place. So how you people connect each and everybody's system? You require a lease line, you require an internet connection, you require a WAN, you require routers, you require switches. So from there comes the term networking. So networking is required to connect each and every system together so that all of those systems communicate with each other internally. That's why networking is required. So it's an interesting class today. So I'll play one video for you, and that's a very good video because I have seen that video twice. So just everybody go through this video. It's a very knowledgeable video for you people. You enjoy listening it. Okay, shall I play the video? This video will cover the basic concepts of networking, IT networking. Shall I play the video, everybody? Sandeep says okay. What about others? Sahir, Shibin, Sanobar, Kelvin, Prabha. Prabha says yes. What about others? Sahir, Shibin, Sanobar, Kelvin. Is my voice reaching to everybody? Kelvin says yep. Okay, so I'll play the video.
Network Associate, Day 1. Welcome back everybody. I am Imran Rafai, your trainer for this entire series. Today we would be starting with network fundamentals. And when I say fundamentals, we would deal with the very, very basic of the networking industry. So this video ideally is not only for the people who are going for the CCNA certification, but anybody who's interested to or looking to start a career in networking. Feel free to watch this because you are going to learn a lot. But CCNA as a certification, it's a very, very valuable certification, and I urge everybody to go ahead and take that certification because it is going to add a lot of value. Before I go any further, I would ask everybody to concentrate on the first 3 days of our video because we would be covering a lot of very, very basic concepts which, if I can dare, I would say it is going to be the base of your entire networking career maybe even 20 years from now. So please concentrate and be clear with every concept we cover here. And in case you still have doubts, please feel free to email me at imran.rafai@nwking.org. That is imran.rafai@nwking.org. Alright, without further ado, let us get into our video. Let's start with the very basic question: what is a network? Well, whenever I ask this question to my students, more often than not, I get answers like Facebook, Twitter, Picasa, whatever that you see here on the screen. But, well, that is social network. That's not the network we are here to learn. And that definitely is not the network I am going to talk about. What I am interested in is this network, the network between computers. Well, this network is also the foundation or the base on which applications like Twitter, Facebook, Picasa, whatnot is built on. So we will learn about this network, and maybe if we have time over the course of this series, we will also talk a little bit about those applications here and there. Right, when I was preparing for this video lecture, I was preparing this image that you see in the screen, and I was thinking, okay, let me see how do I explain this concept to students who are starting on the networking industry. So how do I explain this concept without actually using a lot of technical terms, or saying, okay, this thing communicates with that thing over this thing? I mean, it was difficult, and then I thought, okay, I need a better way to explain this. And I remembered a story that a teacher of mine told me when she taught me networking. It's about the olden days of how kings exchanged messages with an ally. They would pass the message to a messenger who used to ride on horsebacks, and they used to go through all these, the paved path along the roads, and then they used to go through the city gates, and then they used to go to the other king and deliver the message. So if you compare that to a computer network, the messenger sending the message, so the message is like the data that you send. Data could be anything. It could be a doc file, a Word document, or it could be an Excel file, it could be an image, it could be video, it could be anything, the data. And the road on which the messenger traveled, that basically is the network. Of course, computer network is much more interesting than just paving roads. But if you see, that is the very reason why computer network is invented, to communicate between computers. Now if you see this image, you would see, let me just take a highlighter. You will see that we have the Windows PC, we have Linux systems, an iMac, and we have a laptop, mobile phone, Palm Top, you have web servers, maybe it's running on CentOS, you have database servers, file servers. But in spite of they all running on different operating systems, they all can communicate absolutely perfectly with each other. This is the magic of computer networks. The computer network runs on a global standard called the OSI models and things like that, which defines clearly what, when any manufacturer manufactures a networking device, what and how they should communicate with each other. So they all know the language of networking, and that enables them to communicate with each other. Let's try to break this a little more further and see how internet works. So if you look at the picture on your screens, this is the very basic network. Two computers connected with a wire. In this case, we will use a Cat5 cable. A Cat5 cable looks something like this, and this has, they come in different colors. You have the blue color ones, red color ones. I mean, this is obviously another color, and the outer cover is just a protective layer. inside you have 8 tiny cables. These cables go into a connector called the RJ45 cable. That looks something like this that you see on the screen. And on the back of your computer, and most of the computers that you have today, you have a port, a port like this. That is your interface, your network interface card. So your network interface card is where this RJ45 connects, and using this you can communicate, these two computers can communicate with each other. This is the very basic form of networking, and this is called as Ethernet. E-T-H-E-R, net, Ethernet. Let me just write it down. It's sorry about my handwriting, and it's very difficult to write on screen, especially with my mouse, but let me just Ethernet. Maybe for my next video I'll buy a stylus so that I can just write it more legible handwriting. Alright, but for now, yeah, so this cable connects between these two computers, and you can have a very basic networking. But what happens if you have more than 2 computers? So let's say you have 5 computers. I mean, you obviously there's one way, obviously you can go on adding more networking interface cards on your computer, and then you can have. But a better way of connecting is by making use of a networking device, maybe a switch or a hub. Of course, switch and hub are 2 different devices. They have totally different functions. We will obviously learn about them in future video episodes. But for now, you know, we have a networking device. In this case, it's a switch. And these computers can communicate with each other. So for instance, this guy is got a Word document that he wants to send across the network to this guy. All he has to do is send it across to his IP address. What is an IP address, you would ask? IP address is how computers recognize each other on the network. We will learn about IP addresses in the next video series, but for now just know they are identifiers for computers. Another critical reason of why people use networking is because of devices like this. You know, maybe let's assume that this was a very expensive printer or scanner that the company invested in. If networking was not available, the way this device would be connected is to this. Okay, let me just change the color, just show that it is okay, let's use black. So this is, it would have had to be connected directly to the computer. Now let's assume that this user maybe prints 1 page a day, and maybe all the users in this company has similar requirement that they have to print 1 or 2 pages every day. So the company will have to invest on more printers. So you'll have 1 more printer here, this guy will have 1 more printer. So company will have to unnecessarily invest on a lot of printers when the usage of them and all these printers are going to be very, very minimal. Better way for companies to invest money on IT infrastructure is to have one printer, very expensive, good quality printer, plug it onto the network, and everybody can print to it. That's a lot of money saved, and that's a very efficient way of using IT budget. So that is the very basic requirement and the reason why we have computer network. So a computer network in a local office, you know, maybe one home office in a room, you know, in a single company, that's called as a LAN, local area network. And local signifies that it's very local to a geographical area. If this same local LANs, now these are LANs, and you have another LAN here, and let's assume that your company has 2 offices, one in New York and then you have another office in Boston. One way you could communicate, create a network between the 2 offices of your company is, of course, if you had the kind of money that is required to cable from New York to Boston, and of course if you can get the permissions, you could run your own private cable from your Boston office to your New York office, no problem at all. But not many companies have that kind of money, and not many companies would like to waste that kind of money. We have a better way of doing it, you know. You could connect your office to a local ISP. ISP is nothing but Internet Service Provider, and the similar thing happens on the other end. Boston connects their office to an ISP, internet service provider, and ISPs already have their backbone, very massive high bandwidth connections between their offices. So your data that you send from here goes through the network, through the ISP, from ISP to the ISP in Boston, and then through that they go back to the Boston office and a computer. So this computer can communicate with this computer absolutely fine using the ISP. Now this forms the wide area network, where LANs are interconnected with each other to form a very wide area network, and wide here signifies a wide geographical area. It could be across the country, it could be in different cities in the same country, or maybe in different countries. Basically it's a WAN. So that is how it works. Now how do you connect from ISP to your local area network? How do you connect to the ISP? Well, normal situation, what happens is you get a jack on the wall. You might have a small jack on the wall, and your LAN you just connect it to the jack. So from the switch, from the router of your company, you connect it to the jack. The back end, this ISP, they would lay cable. Maybe they would lay it under the ground. They lay a cable to their office, and from their office they go here. From their office again, maybe underground, they lay a cable to the Boston office. Again, there will be a wall socket that is provided, and you just plug a cable from the wall to your router, and that's how your WAN link works. Well, this is also internet, because we're using the ISP. Internet is nothing but a very massive WAN which covers the entire world, where you have a lot of public resources. So if you Google, this is the definition of what an internet is: a global computer network providing a variety of information and communication facilities, consisting of interconnected networks using standardized communication protocols. Whoa, that is a big definition. Well, that's exactly what it is. Internet is nothing but you have a lot of WANs. So you have a WAN here, 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 and then just WANs are connected with each other. So you have another WAN here, and you have another WAN here, another one here, another one here, maybe a few more here. I know in India there are quite a lot. You have all these things, and they are connected. Let's, for instance, you're connected from here, it's connected here, from here you're connected here, this is connected, this is connected, this is connected, this is connected, this is connected. So this is nothing but how an internet works. So for instance, if from India somebody has to communicate to New York, this is how the data will transfer. They will go, if this thing disconnects, you will have the data going through a longer path. So this is what a network internet is. It is just nothing but interconnections of a lot of WANs. Let's find out more about the applications we were talking about earlier. There are a lot of usage of the internet or networking as a whole. We have YouTube, CNN, eBay, Skype. This is just very, 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 very few examples that use the internet. But there are a lot of sites and applications which use the internet, as you already know. Now, how it works is, YouTube, for instance, is owned by Google. So Google has put a public server somewhere on the internet that is accessible to anybody on the internet. So if I want to watch a video on YouTube, I go to my web browser and type www.youtube.com. The process that takes place in the background is much more complicated. I'm just simplifying this whole process. We will look into exactly how it works in further video series. But for now, when somebody types youtube.com and hit enter, my computer sends a HTTP request to YouTube's public server. When the server gets that information, it says, fine, that's an HTTP request. So I send an HTML file back. So it creates an HTML file back, and it sends that HTML file back to me. My web browser takes that and says, that's an HTML file, and I know how to process it. So it processes that and your YouTube website comes live and you see that. It shows a lot of videos and you click on one of those videos, this process repeats, they send you back the video, and that's how that works. So similarly it happens to eBay, you go to CNN, Skype, that's how it works. So this is how internet works. Basically they have a public server, they put all the files there, your computer requests that, they send the file back to you. And this is how internet helps you run this globalized world. When we talk about internet, very critically we need to talk about the speed of internet. Before we get into the speed of internet, let's get to what is the difference between bit and byte. Bit is the smallest information computer can understand. It's either a 0 or a 1. Whereas byte is nothing but it's formed by 8 bits. So 8 bits together form 1 byte. It could be something like 1 1 0 1 1 1 0 1, whatever, something. So that's a byte. So 8 bits form 1 byte. Now a lot of people get confused. Data is always denoted by bytes. So when I say I have 1 GB of RAM, it is 1 gigabyte of RAM. But when I tell I have a 10 Mbps connection, it is 10 Mbps connection, bits per second, megabits per second connection. If you confuse these two, it's going to be very, very difficult. At 1 Mbps, byte per second connection is 8 Mbps connection. I mean 8 times the speed of what it is supposed to be. So speed is always denoted by the small b, data size is always in big B. In computer world, kilo is always 1024. So 1 kilobit is 1024 bit. Similarly, 1 kilobyte is 1024 byte. Right. So for instance, let me see, I have a 1 Mbps connection and I have a file of 128k bytes. So let's say for instance you have Word, and in Word you type the alphabet A. Now with to produce that one alphabet, that takes about 1 byte, capital B, of space. So 1 byte is how much it needs to store this alphabet A. 1 byte is about, it is 8 bits, right, according to the current version. So to type A, it takes 8 bits or 1 byte of data. Alright, having known that, let's look at this example. So you have 128 KB, that is byte, a file of 128 KB. Now it needs to go across a network with speed of 1 Mbps, 1 megabits per second. How much time will it take? It's a very simple question. Let's try to convert. 128 kilobyte, if we convert into bits, it is 128 into 8. This conversion, if you know, bit, byte, it's 8, right? So 1 byte, 128 byte is into, if you convert it into bits, it is 1024 kilobits of data, right? So 124 kilobits, where is that? It's here. 124 kilobits is nothing but 1 megabit, right? 1 megabit. What's the speed? It says 1 megabit per second is the speed of our connection. So on a connection of 1 Mbps, 1 MB file will take exactly 1 second. So that's what speed is. So understand this, the difference between speed and data, the difference between bit and byte. So if you can understand the difference between bit and byte, the whole process of understanding further videos is going to be very, very easy. When we talk about speed, we need to also talk about 3 other critical factors: that's speed, delay, and availability. 3 of them always go hand in hand. Like for instance, now when you connect a cable from your router to your PC, it tells you that it's connected at 100 Mbps. That's because today our LAN card, the maximum they can do is 100 Mbps. But then don't forget that speed that they're telling is the speed between your computer and the router. Your internet connection may be a 1 Mbps connection. So if you send 100 Mbps data, 100 MB per second data, it will not go through your internet, because your internet can only do 1 Mbps. Similarly, you go let's say for instance this is your Bangalore office to your New York office. We are sending a file. So from Bangalore office, it goes through a gateway. From gateway, we have a 1 Mbps slow connection. It comes to our Bangalore ISP. Bangalore ISP to Mumbai ISP, they have a 100 Mbps line, very fast. And then from Mumbai to Dubai, they have a 10 Mbps line, a little slow connection. From Dubai again to Cairo, they have a 100 Mbps line, and then Cairo to Madrid, let's say you have a 100 Mbps line. So similarly, they have a smaller, higher, different speeds around the world. So basically, when I say net to internet, this is what happens. Internet, if you pull off the cloud, it is nothing but a lot of routers jumping here and there. Now, even if I have a very high speed connection, your data throughput between your Bangalore and New York office will depend on slower connections in between. So even if I had a very high speed connection, a 100 Mbps line in Bangalore, right, it can only travel at the slowest link in between. So our slowest link is the 10 Mbps line that we have here. So from New York office to Bangalore office, it will always, the maximum it can do is the 1 Mbps line that we have in New York. So this is how it works. So I mean, this is not the exact data flow from Bangalore to New York. I've just giving an example. It need not always go via Dubai and Cairo. Maybe it goes through some other location. But basically, it actually the data packet flows through one location to another location to another location. It goes. So, like I said, the speed always depends on different factors of the link speed that you have in between. Again, there's a critical factor is of delay. Now, when I send the data from New York to Bangalore, it has to, like we already discussed, it has to pass through a lot of nodes in between. But let's assume that we have another office in Boston. I love Boston, don't I? So let's say we have Boston office, and we send data from New York to Boston. It has to pass through less number of nodes, and hence it would reach much more quicker. So that's another factor. If the distance between the two devices is long, you will have delay in the communication. And that's why today, if you go to Google, I mean, even google.com, for instance, or you go to youtube.com, they redirect you to a content delivery network closer to your place. So if you are in Singapore and you say google.com, or you go to youtube.com, the YouTube would not connect you to the Google server or the YouTube server in the United States. It will connect you to a content delivery network close to Singapore, maybe in Singapore, so that there's not much delay, or there's insignificant delay in the communication, and the whole process is much more fast. So that's the delay part of it. And the availability, again, for instance, the link between Cairo and Dubai is down. Communication between New York and Bangalore would not happen, or it would happen, but then it has to take maybe a longer path. You might have another path which goes via Russia, and then it comes via it goes via China and comes to India, and it's a long process. So that's another thing about availability. Availability is if all the links in between are up and running. Another thing we need to discuss in today's video is network topology. The network topology, there are three fundamental network topology: the star topology, the ring topology, and the bus topology. The very olden ways of how computers were connected, but even in today's world, they are in use. I will show you how. Now, for instance, star. How does star work? Star is where all the computers or devices are connected to a central switch or a connecting device. Now, if this line goes down, it doesn't affect everybody else. Only this guy goes off the network. So in ring, for instance, every computer is connected to each other. So if this guy goes down, the communication between these two devices can still happen through this way, right? So that's how this works. Now in bus topology, let's say for instance this is again like that. You have a device here, this is connected to this device, you have another device here that is connected to that. So every computer is connected to their own little device, right? Now if the link goes down here, this part of the network can communicate with each other but not with another device from the other segment of the network. That's how a bus network works. Let's see how it is implemented in today's world. We go back to our old example that we saw earlier in this video, and if you see, the switch and these systems or these PCs are connected in a star formation. Everybody is connected to this central switch. Here the server also similar thing happens, you know, everybody is connected to the switch. These devices are connected to the access point in star formation, or and you know, so to say. And if you look at the switch is connected in a bus formation. Now if the link goes down here, this part of the network can communicate with each other, but it cannot communicate with anybody else from this part of the network. Sometimes you might even have networks where this is connected like this and this is connected like this. So even if this goes down, the switch can still access this network around this path, and they can, you know, get access to these windows, I mean these systems here. So in real world, the network topology that we use is called hybrid, which makes use of the star and the ring, and maybe even the bus. So it's a combination of all the three or either of them, and that's how it is. So it is a hybrid network that we use in today's world. I think that is about all the information that I wanted to speak about in this first video. We will further get into a lot of other topics in our second video. This is the review of what we did today. Go through all the topics that is mentioned here and see if you understood any. If you didn't, you can always go back and try to learn a little bit more. And even after that, if you have confusion, if you want more clarity on any topic, please feel free to write into imran.rafai@nwking.org, and I will look into it and I will answer your queries. And of course, subscribe to our YouTube channel, and you can keep getting all our videos live on YouTube. Thank you for watching, and please visit our website. Bye.
Enjoy this video, everybody. It's a very good video on IT networking. So in this particular video, basic concepts of IT networking is being displayed. So do you all enjoy this video, everybody? The basic concepts: bits, bytes, topologies, routers, switches, LAN, MAN, WAN. Any questions, any doubts? Anybody wants to ask anything? Kelvin says satisfactory. No, not done. I'll be something extra. I have to show it to you. Any questions, anybody? Any doubts till now? What about others? Renzi, Sanover, Shibin, Kelvin. Okay, so very quickly just play the second video for you, and I request everybody to note down all the important points which you see in the video, or if you want to note down something you can ask me. Yes, topologies are nothing but there are three types of topologies are there, as you have seen. One is the ring topology, another is the star topology, and third is bus topology. So in ring topology, if you can see on the, you are able to see the video. I have just paused the video. On the video screen, can you see everything, Kelvin? Okay. So in what you do in star topology, that all the computers are connected through one switch in between. If you see, all the computers are in the form of a star. It forms a star. So all the computers are one-to-one connected with the switch in between. So what is the drawback in that? Plus point. What is plus point? Plus point is that all computers, whenever one computer has to communicate to another computer, it has to go through the switch. That means one computer cannot directly contact or communicate with other computer. So that is a drawback in that, and also the electricity consumption is pretty much high. From there comes the concept of the ring topology, the second one. The ring topology is each and every system, as you can see in the ring, are connected in the form of a ring. That means one computer can communicate to another, second can communicate to third, and so on. So all computers can communicate to each other. That is the ring topology. So then third is the bus topology. Bus topology is that you have a common line, or you have a LAN cable. You have a LAN cable in the office. What you do in the office, you have a LAN cable being circulated. You have a wire cable being circulated in the office. What you do is you plug in your computer to the, you attach your computer to that particular point through a cable. So you started using that. That is the bus topology. That is the concept behind the bus topology. So there are three types of topology: star topology, bus topology, and ring topology. Nowadays, since communication networks are very, very complex, so we are using star topology with ring topology, or we are using star topology with bus topology, or we are using all the three topologies together. So when we are using more than one topology, it is called as a hybrid topology. Hybrid topology. Hybrid topology means topology of one or more. That means maybe it's a star plus bus plus ring together, or it's star plus bus or maybe it's bus clustering, etc. Okay, Kelvin, is your doubt clear now? Okay, so very quickly just go on to, I am going to another video. So just everybody watch this
Associate
video.
Day 2. This is Imran Rafai, your trainer for this entire series. Welcome back everybody for the second day in our training series. As you already know, this is a free training on YouTube for all the people who are interested to start a career in networking. In our last video, we learned about network funding. Would be dealing with the OSI reference model and TCP/IP model. When I say TCP/IP model or OSI model, it is nothing but a set of rules. It's a set of standards. Now you might ask, why do we need a set of rules or set of standards in the computer industry? To understand that, we need to learn a little bit about the history of the computer industry. Not long ago, there was a fierce battle between IBM and Digital Equipment Corporation to become the leading computer manufacturer. But there was a problem. Both these manufacturers manufactured devices which were not compatible with each other. So if you bought a computer from IBM, you had to buy a monitor and printer and everything from IBM. Similarly, if you bought a device from Digital Equipment Corporation, then you had to buy all the accessories and all the other devices from Digital Equipment Corporation so that you can actually use it. There were many companies which bought equipment from both the equipment manufacturer, such that the accounts department had IBM computers and devices, and the marketing department had Digital Equipment Corporation computer. But the problem is they could not communicate with each other, or they could not even share information with each other. Now that was not the right way forward. That was about the time when International Organization for Standards, or more commonly known as ISO, thought that there was a need for a standard. ISO developed OSI, which is an acronym for Open System Interconnect, which is more commonly known as the OSI reference model. At about the same time, a competing standard known as the TCP/IP model, which was promoted by the Department of Defense, came into being. The TCP/IP model is more like a stripped down version of the OSI model, and because it was more relevant, it went on to become the industry standard. To understand a little bit more about the models, we need to understand about layered approaches. To understand that, let's talk about this office that you see on the screen. Every office has different employees and employee levels. So you might have a CEO, you might have senior office staff, you might have payroll manager, an account manager, maintenance manager, you have maintenance staff, you have junior office staff, and you have different staff. The reason every companies have different employees with different designation is because all those people have different roles and responsibilities. So when you know that something is not done, or some task is not accomplished, you know who is responsible. For instance, if your salary is not credited on time, you know the responsibility has to be with the payroll manager. Whether the bank is involved or that's secondary, but the payroll is your first point of contact. You will need to go and speak to the payroll manager. If you come to office one fine day and you see your office really dirty, it's not cleaned, you know the janitor is responsible, or the maintenance department is responsible. So you know where the responsibility lies. Similarly, we learn about the OSI model and the TCP/IP model because in learning about the computer networks, or tomorrow when we are troubleshooting computer networks, we need to know what works at what layer. So if something isn't working, instead of troubleshooting all the equipments, we know exactly where the problem is. That is why we have a layered approach. Alright, knowing what we know now, let's get into the models. Let's understand how models work, what are the layers involved, and let's compare TCP/IP and the OSI model. What you see on the left is the OSI model. What you see on your right is the TCP IP model. Let me take a highlighter so that I can highlight as I talk. Alright, for the moment, don't worry about the colors. I have color coded it to compare between the OSI model and the TCP IP model. So let's start discussing from the left, from OSI model. Before we go any further, I need to stress on this point that as a student of networking, all of you should know the layers by heart. So when I say that, you need to know exactly the sequences of the layer. You need to know layer 7 is application layer, layer 1 is physical layer, layer 5 is session layer. You just need to know where the layers are. One way of remembering the sequences of this layer is by having mnemonics. One of the most popular mnemonics to remember the OSI reference model is the one given here. So if you remember, please do not throw sausage pizza away. You can remember the first letter of the layers from bottom up. So please do not throw sausage pizza away is PDNTSPA. Similarly, some people would want to remember the layers from top to bottom, which is perfectly fine. So if you want to remember it from top to bottom, then you have another mnemonics which says all people seem to need data processing. Well, it's up to you. You can do it the way you like it, as long as you remember that physical layer is layer 1 and application layer is layer 7. Some people get confused when they remember it from top to bottom that application is layer 1. No, application is layer 7, physical is layer 1. Alright, and if you want to remember TCP IP model, then you could remember by just remembering this mnemonics, which is TCP IP comes in a tin. Well, it doesn't mean anything, but you can just remember a tin, that is application, transport, internet and network interface. Like I said, if you have a better way of remembering, please use it. As long as you remember the sequence of these layers, it should be perfectly fine. Alright, let's start with the application layer. Application layer is the point of contact for all network aware application. Let me repeat that. It's a point of contact for all network aware applications. A lot of authors, I have heard them say that all the applications on your computer resides on this application layer, which is not true. Application layer 1 deals with only applications that is network aware, and all the applications on your computer has nothing to do with the application layer if they do not communicate on the network. To understand that a little bit more, let's assume that you have uninstalled all the drivers on your PC, your wireless network interface card and your Ethernet card, all the network interface card you uninstall from you uninstall the drivers. You can even physically remove if you can. Now if you fire up Microsoft Word, for instance, Microsoft Word will not communicate with the application layer, or for that matter it will not communicate with any of this layer. That is because Microsoft cannot access your network because it does not have your operating system does not even have a network interface card. Similarly, on a normal system, if you fire up your web browser, maybe Chrome, Internet Explorer, Safari or any of the web browsers, and if you type www.cnn.com, that web browser creates an HTTP request. It communicates with your application layer. The application layer gives that data to the presentation layer. The presentation layer does what it has to do, gives it to the sessions layer. Sessions layer does a similar thing. It gives to transport, and it keeps passing it to the next layer until it reaches the physical layer. So this is how it works. So if an application communicates with the network, that's the only time application layer is invoked. Some of the protocols that work on this layer are FTP, TFTP, SNMP, DNS, HTTP, and there are quite a few. So you can just do Google, you will get the entire list of all the protocols that work at this layer. Next we'll deal with the presentation layer. The presentation layer is the layer which generifies data. When I say generifies data, it's a layer which takes the data coming from sessions layer on the way back, converts it to presentable form, and gives it to the application layer. So if you have raw data coming from sessions layer to the presentation layer, this is where data is converted. So if it's an image, it creates an image. If it's a Word document, it creates a Word document. So presentation layer is where all the data conversion happens. Also, all encryption services like TLS, SSL, all that are taken care at this layer. Next, we have the sessions layer. Sessions layer is the layer which creates and maintains session. When I say that, let's assume your computer has two applications. You have your telnet program and you have your web browsing application, maybe Internet Explorer. Now both of these applications are accessing the network. So this layer is which creates two separate sessions and maintains them. So when your web browser session is terminated, your telnet session also will not get terminated because they are separate sessions. So it maintains different sessions. Now I've color coded the top three layers in blue, and the reason I have done that is because as a network engineer, and especially as a Cisco network engineer, there's very little that we need to deal with layer 5, 6 and 7. That is because most of the Cisco devices will not look beyond layer 4. So layer 1, 2, 3 and 4 are very critical for a Cisco engineer, but 5, 6 and 7 are not so critical. You just need to know how it works, and you know, as a rough idea, you know what it does. That should be perfectly fine, because layer 5, 6, 7 are taken care of by the operating system. But layer 4, 3, 2, 1 is where, as a network engineer, you have to know exactly how that works. Right. Next, we learn about the transport layer. Transport layer is also one of the critical layers for a network engineer. When the information coming from the upper layers comes to the transport layer breaks them into manageable segments. Each segment, transport layer adds its own header to create an encapsulation. Two critical decisions the transport layer takes is one, whether to have reliable communication or unreliable communication. Second is to create a port number. When applications need a reliable communication, transport layer uses TCP, which is nothing but an acronym for Transmission Control Protocol. If it wants an unreliable communication, it uses UDP, which is nothing but an acronym for User Datagram Protocol. When I say reliable, it doesn't mean it is better than unreliable, in that the only difference is reliable communication has to get an acknowledgement for every packet that is sent. In unreliable, there is no acknowledgement that is received for every segment. Right. Next, we learn about the transport layer. Transport layer is also one of the critical layers for a network engineer. When the information coming from the upper layers comes to the transport layer breaks them into manageable segments. Each segment, transport layer adds its own header to create an encapsulation. Two critical decisions the transport layer takes is one, whether to have reliable communication or unreliable communication. Second is to create a port number. When applications need a reliable communication, transport layer uses TCP, which is nothing but an acronym for Transmission Control Protocol. If it wants an unreliable communication, it uses UDP, which is nothing but an acronym for User Datagram Protocol. When I say reliable, it doesn't mean it is better than unreliable, in that the only difference is reliable communication has to get an acknowledgement for every packet that is sent. In unreliable, there is no acknowledgement that is received for every segment transmission. So unreliable is actually faster, because of the less overhead. So if it is real-time applications will use UDP because it is faster and it is real-time. So most of the time, if you have tried watching an online transmission or a live feed, there are times when we see those green pixels on the screen. This is nothing but the information for that pixel had not received, and the receiving device had no way to tell the sending device that it had not received that pixel. Similarly, another function that is taken care of by the transport layer is to create port numbers. Port number is a number that is attached with the IP address to identify which application this information is coming from. So the transport layer creates a random source port number, and then it attaches the port number for the destination. So if your traffic is going to a web server has a standard port number of 80. So if you're going to an IP address 10.10.10.10, for instance, just an example, at transport layer it takes 10.10.10 and it adds a port number of 80. So it creates a socket. Socket is nothing but an IP address and port number. It creates socket and it sends down to the network layer. It also adds a source port number. Why does it require source port number? The reason it creates a source port number is because if there are two applications running on your computer and it is going to the same IP address, when the reply comes back, transport layer needs to know which data goes to which application, and it will identify that by actually having your source port numbers. Next, we learn about the network layer. When the network layer gets a segment from the transport layer, it adds a network layer header. When a network layer header is added, that information is called as a packet. So one of the critical functions of the network layer is of IP addressing, or also known as logical addressing. We will learn about IP addressing in the next video, day 3, but just know that this is where IP address is added. It also finds the best path. So when I say best path, it compares the IP addresses and it checks if the destination IP address is in the local subnet. If it is not on the local subnet, it will find the best path to go to the destination. Next, we have the data link layer. When the packet comes from the network layer down to the data link layer will add a data link header to it, and that information is called as a frame. The data link layer is responsible for MAC addressing. MAC is nothing but an acronym for Media Access Controller, and MAC address is a hardware address. That means every network interface card of your computer has its own MAC address. MAC address is also known as burnt-in address, and it's an address that cannot be changed. Yes, there are ways of spoofing the address, but it cannot be changed physically. This is also a layer where error checking happens. So when information coming from the physical layer to the data link layer, the data link layer has the ability to check if there were errors that was induced during transmission. So it could use a cyclic redundancy check, CRC, or it could use parity check, and there are other error checking mechanisms that data link layer uses to check for errors. Next is the physical layer, and physical layer is where the actual data transfer happens. This is the layer which deals with wires and cables and your hardware ports and hardware connectors. All those things happen at this layer. So as a computer engineer or as a network engineer, when somebody tells you that the internet does not work, as an engineer you will start working or troubleshooting from physical layer. First you will check the cables to see if it works. If the cables are fine, next you will check for your layer 2 problem. Then you'll go to layer 3, layer 4. So you will troubleshoot by layers. And that is why we have to learn about models. Also, any change in one of the layers will not affect the adjacent layer as long as the standard is followed. So if for physical layer, instead of Ethernet cable, I choose to use wireless, it should not matter because the change happening on the physical layer only. So data link layer, as long as it gets information the way it is expecting it to get, it does not matter how physical layer gets those information. Similarly, the network layer, I mean, we are in the transition phase of going from IPv4 to IPv6. So that change is only to layer 3. Layer 4 and layer 2 will not get affected as long as the standard is followed and it receives the data information the way it was expecting it to receive earlier. So that is the beauty of the layered approach. Now if you compare the left and the right, we can see that layer 5, 6 and 7 is comparable to layer 4 of the TCP IP model. Transport layer and transport layer of TCP, they have comparable functions. Similarly, the network layer and the internet layer. The layer 1 and layer 2 of OSI model is comparable to layer 1 of the TCP IP model. Next, we will just see the OSI model working. Let's assume the guy on the left wants to send something to the guy on the right. So he creates a data. Like we mentioned, the top 3 layers are generally known as the upper layers, and upper layer we really don't deal much. So let's assume the data goes to the transport layer. What the transport layer does is it takes the data, it segments it and adds its own header. So you see you have a transport header here and you have a transport header here. Next, let's assume we are dealing with UDP here, so it is not waiting for acknowledgement, so it will send segment 1 to the network layer. The network layer, as we know, will add a network header to it and it becomes a packet now. Now network layer will give segment 1 or the packet to the data link layer. So data link layer takes that and adds a data link header. And if you can see, segment 2 also goes through the same process. Next, the segment 1 goes to the physical link layer, and the physical link layer, as we know, will convert it into zeros and 1. So our segment 1 got converted. Next, segment 2 also will get converted. By that time, the physical layer of the destination device would have taken those physical bits or physical layer bits and converted it into segment with the appropriate headers. What the receiving layers will do is it will strip the headers of the corresponding layers from the source. So data link layer will remove the data link header and give that information to the network layer. So if you see, there was a data link header to segment 1 which the data link layer stripped and gave that information to network layer. Similarly, it will happen to segment 2 as well. So for segment 1, when it goes to transport layer, this network header will get removed. So if you see there, the network header got removed and it reached the transport layer. Next, the transport layer will wait until it gets all the segment. That's what the transport layer will do. So transport layer waits until segment 2 comes there. Now transport layer will strip all the transport layer headers and combine that information and give it to the upper layers. So that transport layer combines it and it is given, and the receiving guy receives the same data. And this is how a very basic representation of how a data network works. I think that's about all the information that we had to learn in this day 2 video series. Please go through this entire cloud map and I'm sure you understand all the topics here, but if you do not, please feel free to write into me at imran.rafai@nwking.org. Please don't forget to share our videos, like our videos, and please subscribe to our YouTube channel. Your love and your respect is what motivates us to create free content. Thank you so much. So let's assume the data goes to the transport layer. What the transport layer does, data link header to segment 1, which the data link layer stripped and gave that information to network layer. Similarly, it will happen to segment 2 as well. So for segment 1, when it goes to transport layer, this network header will get removed. So if you see there, the network header got removed and it reached the transport layer. Next, the transport layer will wait until it gets all the segment. That's what the transport layer will do. So transport layer waits until segment 2 comes there. Now transport layer will strip all the transport layer headers and combine that information and give it to the upper layers. So that transport layer combines it and it is given, and the receiving guy receives the same data. And this is how a very basic representation of how a data network works. I think that's about all the information that we had to learn in this day 2 video series. Please go through this entire cloud map and
so that is the video on the two models on which the computer networks work. One is the TCP IP model and second is the OSI model. So with these two video lectures, I think you will be able to have the basic idea of IT networking, what exactly IT networking is, because in these two videos all the basic contents related to IT networking is being displayed. So I think it's Prabha that who has asked for the class on IT networking some days back. Is it so? Somebody has asked me to have a class on IT networking. I think it's Prabha. Okay. Yes. So everybody in the class, do you enjoy this video on IT networking? Do you able to understand the basic concepts behind IT networking, how IT networking works? Now after seeing these two videos, when you start reading certain good books on IT networking, you will definitely be able to understand more on IT networking, because basic is already being covered in this video. So any doubts, any questions, anybody wants to ask anything? Any doubts, anybody? If you want to know more, you just consult some good foreign writer books. There are a lot of certifications, exams also. If you want to make a career into networking, that is CCNA is one of the certification and CCNP is another certification. You just can type this CCNA and CCNP into the Google and you will come to know more on these certifications. These are senior level exams for making your career into IT networking. Yes, that's right, on Google. So thank you all for your time. I think class is going to get over in 15 seconds. Hope everybody have enjoyed today's class. Just do give your feedbacks after the class. Thank you all. Take care. Bye-bye.